Hi friends, so in this video we are going to learn about circular singly linked list or also known as single circular linked list. Okay, so what is a single circular linked list? It is similar to a singly linked list where we have the nodes with the data path and the next pointer pointing to another node. Okay, and here also we have one data and it is pointing onto another node. It is at address location 300. Then we have the data here. Okay, and we have this node. So in single linked list we had the null pointer here, but in circular linked list instead of null we are going to store the address of this first node, that is the 100 address. Okay, so this first node is present at memory location 100, then it is at 200, 300 and 400. So we are storing the memory address of the very first node, hence this is pointing to the first node. So this is our single circular linked list, also known as circular singly linked list. Okay, so it is similar to the single linked list. The only difference is this extra link that we have provided by replacing the null pointer of the last node with the first address, or you can say with the content of the head pointer. Okay, so if for this circular linked list, if we have to find the total length of this, so how we can do? Like in single linked list, we used to find with a list length function, and we had a pointer q, and we used to traverse to the entire linked list, and we had a integer count. We keep on incrementing its value till we get till we have the q equal to null. We come out of the loop and we return the count like so. Okay, so in this case how can we find the total length of the linked list? So let's see. It is similar to singly linked list only, just one difference for the last node. Okay, so let us say this is our function int circular list length, and here we are gonna provide the head, of course, node pointer head. Okay, so this will be returning an integer count value. We are setting initially the count to 0. Okay, and we have one node pointer p here. So this pointer will be used for traversing entire linked list. So if head equal to null, that is if there are no node in the linked list, then definitely we are returning the count as it is as 0. And but if there are some nodes in the linked list, that is in the else, then we are first assigning this p as head, and we will be traversing to the linked list till we are getting the p value as equal to head. So initially we have this head, and we are going to traverse down till the entire linked list, and at the end we are getting some p as 400, and then p will be pointing to the next and it will be 100. So we are going to traverse till we are getting p equal to head. So in this way, p, since p is already equal to head, so we are doing this like do count plus plus for incrementing for one node, and we are moving the p to next of p, and then we are checking for this condition while p not equal to head. I mean, we are doing this for if until p is not equal to head. When p becomes equal to head, then we will stop. Now see this do while we have used because we initially we have the p assigned to head. So if we are comparing like while p not equal to head, so it won't come inside the loop also. So you understand, like if we have this something like while, like we were already doing, while p not equal to head, right? So we are doing this count plus plus and p equal to next of p, and when p becomes equal to head, we are returning the count, right? So here also we are returning the count here. But the thing is, we have used here do while loop. The reason why we have done this, because initially we are assigning the head to p, and now we are comparing while p not equal to head, but p is equal to head, right? P is not equal to head. This won't be true here, because this will be false because p is already assigned to head. Okay, so we won't come this inside this loop only, right? So that is why we have switched our approach as such, like we are first incrementing the we are entering inside this do loop, incrementing the count, and then we are incrementing the p value, then we are checking, and of course this gets false because p is assigned to the next of p, and finally when it becomes equal to head, we are returning the count. So this way we can find the total length of this linked list, circular linked list. Okay, so that's all about this video. Thank you very much for watching.